this is the best. Okay. There was one that I did not put up in time. So if you look on your syllabus, I was indicating changes that I wanted you to make on your next draft. That was technically due on the 17th, but I forgot to put it up on my Kadi. So it is technically due by this Friday. So give me a couple of sentences on what you're going to plan on doing with your next draft. You have feedback from me now, so you know what you need to do. Please don't repeat my feedback verbatim. Like, I don't like plagiarism, and I like it even less when you plagiarize from me. Nobody has ever plagiarized one of my papers yet. That's not actually a challenge. Please don't do it. The other two things that I wanted to let you know about, we have a chapter 14 handout. That'll be due next Friday on the 8th. And then I want you, for homework number 15, I want you to share with me something that you learned in this class that you can take forward with you into capstone, graduate school, career planning, another class. Tell me something important that you got out of this class. So I want you to take some time to think about it. And that's just on e-learning, and that is also due on the 8th. Okay. So we're going to finish up by talking about our final, I'm going to go ahead and duplicate. We're going to go ahead and talk about our final thing in this class, which is one independent variable extended design. So this would be an instance in which you have one independent variable with more than two levels. So for example, if I'm looking at the effect of age on memory, and I have a group of children, I have a group of young adults, and I have a group of older adults. That would be a case where I have an independent variable that has three different levels. So here's what we're going to talk about, and I'm going to try to keep it pretty short. Many years ago, prior to 2019, I actually went into a lot more detail about how to do an analysis of variance, and I think I just confused all the students. So I'm trying to kind of pare it down here to mostly show you the basic premises of how you do an analysis of variance. So we're going to look at a one-way independent groups design. We're going to look at comparisons and contrasts of means with confidence intervals. Yes, we are still doing confidence intervals. We'll talk about planned and exploratory analysis. And then we'll talk about one of my favorite types of research designs, a one-way independent or one-way repeated measures design. And we'll talk about what is called an analysis of variance, or ANOVA. Now, I'm going to take a slightly different tack from your book. Your book is all about estimation, and it's basically confidence intervals good, null hypothesis testing bad. I would say for undergrads, though, ANOVA might actually be a bit more intuitive than confidence intervals might be. I think ANOVAs are actually pretty good for beginners, and I'll tell you a little bit about why I think that when we get more into the details of what ANOVA is and how it works. So let's talk a little bit about the one-way independent groups design. So I don't know how many of you might remember this. Do you remember last semester when we talked a little bit about things like factorial designs? Maybe a little bit. Some of you are saying yes, some of you are saying no. So let's go ahead and give an example. So one of the things that we find, let's say that I was looking at some factors that relate to health, for example. So I could do a study and look at the effect of diet on health. I could do a separate study and look at the effect of things like physical activity on health. But one of the things that we know is that in the real world, factors interact with each other. So for example, these interactions happen all the time. For example, I am taking allergy medication right now. One of the fun things about going from California, where there's not a lot of humidity, and then coming back here where there's a ton, is that my allergies hate me right now and I'm very congested. so I'm taking allergy meds. Now, allergy meds on their own are not going to really have that much of an effect on me. I take things like Claritin that are non-drowsy on its own. Maybe one cocktail with my friends or a beer with my friends will not have much of an effect on me. But if I mix the two, we know that alcohol can have interactive effects with different types of medication, especially allergy medication. And unfortunately for me, sometimes I have forgotten I'm taking 24-hour allergy medication. A glass of wine is fine. No, don't do it. But what I'm saying is that in the real world, factors that you're interested in interact with each other. And what's more, maybe you can't afford to run a separate study for every factor that you want to look at. So extended designs with multiple independent variables or multiple levels can address questions that a simpler study can't, and they can help save us time and they can save us money. So what you're looking at here is data from a one-way independent groups design. This is a case where we have a single independent variable with 3 or more levels. And there are 3 different groups. Each group only experiences one level of the independent variable. So what you're looking at here is a study, some sample data from Bushman back in 2005. And basically, Bushman was interested in whether people paid attention to ads. Do you pay attention to advertisements? No, oh, you do? Nice. I click past them because I pay for YouTube Premium, so I do not have to look at ads. So Bushman was interested in how much people would pay attention to ads based on the different content that they watched. So, would the type of content that you're watching make you more or less likely to pay attention to the advertisements? So Bushman basically had 3 different groups of people, and each of those groups of people was watching a different show. So the people that got neutral content, I forget what it was off of the top of my head, but I think it was something like America's Funniest Home Videos or some sitcom or something like that, like neutral emotional content. But there's this idea that things like sex or violence might be more attention getting. And so Bushman had 2 additional levels where people were either shown violent content, they watched the show Cops, or they watched sexual content, they watched Sex and the City. And basically, regardless of what group you were in, everybody got the same advertisements. So the only thing that is differing is the television content that people received. All of the ads were the same. And then participants had a surprise memory test for the advertisements. And basically, they did a test of brand recognition. They would show a brand to people and they would say, did you see this or did you not see this? Was this a brand you saw or is this new? And so if you look at the data here, can somebody share with me what conclusions you could draw from this data right here? Yeah, Sarah.
You're able to better recognize if you saw something before you're watching something not violent or sexual.
Okay.
And then it goes down. So like something violent, you're more likely to recognize something you watch.
Okay. Do you think that's a sizable difference though?
No.
Why not? There's a lot of overlap here. There's not a lot of overlap between this and this or this and this, but there's some overlap here. So maybe the effect of violence versus sex is negligible. But what this kind of tells us, you're exactly right, Sarah. They had better brand recognition for neutral content compared to violent or sexual content, which means, based off of Bushman's idea, that showing attention getting content actually ends up hurting your memory for advertisements. So Bushman suspected that participants may recall ads less when distracted by sexual or violent content. So basically the question that we're asking with these confidence intervals, remember that with estimation, we're asking things like, to what extent, by which amount. So to what extent would violence change memory performance or sexual content? There are 12 brands that are recognized here. So no, this is basically 0 through 7 out of 12 total brands. So basically, one of the things that's kind of nice about looking at confidence intervals when you have multiple levels, we're not learning anything new here. Do you remember way back when we were doing comparisons in a between groups design? We're basically going to do that here, but we're going to choose in advance what groups we wish to compare, and we're going to do different pairwise comparisons. So the analysis stays simple by focusing on predetermined selected comparisons or looking at the differences between two means that relate to the research questions. And folks, this would be the same if you had 4 groups or 5 groups or 6 groups. You would want to pick and choose which pairs you want to compare with each other. Your chapter 14 handout is comparing different types of chocolate. I gave you fake data. You get to plug it into Esky. So if you need to borrow my computer next week for Esky, I'll bring my computer during writing week. And remember that all of the paper is due on Tuesday at 3 o'clock during finals week. That's the 12th. I will send you a link probably sometime tomorrow to a video about how to write a title page and how to write an abstract, because you're going to need to do that for this one too. And you need a references section, so go back and take a look at your last references section that you turned in. And if you need a copy of what you sent me, let me know. Okay, so basically what we see here is that viewing a violent or sexual show significantly reduced the memory of ads compared to neutral. So basically what we are doing is a lot of what we did before. We're going to be looking at S pooled again. You're like, yay, S pooled. But we're going to spend a lot of time we're not going to really do a lot of math equations here. But basically, this is the general strategy that you want to use when you're analyzing a one-way independent groups design. By the way, we call it one way because we only have one independent variable. If we have 2 independent variables, we might call it a factorial design. We may also call it a 2-way. If we have 3, we can call it a 3-way. If we have 5 or 6, like Dr. Gilchrist has sometimes, I have occasionally found a 5-way interaction before. I do not recommend. Nobody knows what a 5-way interaction is. So what you're going to do, you're going to select a small number of comparisons that correspond with your research questions. So that's the first thing you're going to do. At that point, you are going to focus on the selected comparisons, and you're going to use confidence intervals to interpret. In this case, you're going to do what you did back in chapter 7. You're going to get the confidence interval on the difference, and you're going to draw conclusions based on that. And we're going to calculate S pooled. Y'all remember this, right? You're like, how could we ever forget Dr. Gilchrist? It was scary. So here, what we're basically going to do, I'm going to pick which means or which groups I want to compare ahead of time. I'm going to calculate the pooled standard deviation for them. And just as a reminder, your pooled standard deviation is a weighted average of the standard deviation for the 2 groups that you're comparing, weighted by how many people are in each group. And if you want to do this for 3 groups, which you do, it's basically the same thing. So if you have 3 groups, you have to calculate this S pooled. And it's basically the same thing, except we're just adding another group. So in this case, instead of a weighted average of 2 groups, we are doing a weighted average of 3 groups. So when you are comparing 2 different groups to each other, you are actually doing the pooled standard deviation based on all 3 groups, not 2 groups. I know, but you know what? I'm not going to have you do that because Esky can do all the hard work for you.
And should I-
Oh, probably. But if you're doing JASP, I would just tell you to do an ANOVA. And I'll show you how to do an ANOVA too. And this basically, our function for our degrees of freedom is similar to. The only difference is that we're adding our third group and subtracting 1. So ultimately, this comes to the total number of people minus 3. So here's how you calculate the margin of error on the difference between independent groups. So hopefully this will be a nice refresher for you. So we have our critical T statistic for 95% confidence and our specified degrees of freedom multiplied by the pooled standard deviation. And in this case, we have our 2 groups. So this would be what you do for comparison. So here's what I want to make really clear because this can get confusing. This calculation is for those 2 groups that you want to compare, but the pooled standard deviation is based off of all 3 groups. So even though you're only comparing 2 groups to each other, the pooled standard deviation comes from all 3 groups involved. So we can actually calculate the margin of error for our individual means here. So if we know all of these, we can calculate this. I am not going to do that for you because Esky's going to do all the heavy lifting for us. Okay. So I'm going to show you this in just a second, but you can do this on Esky for the file that is for chapters 10 through 16. So this will show you a few different things. It will show you summary statistics, and it will calculate all of the information that you need for each confidence interval for each group. And then what you're going to notice is that you have radio buttons at the very top that allow you to pick and choose what comparisons you want to make. So I'm going to go ahead and close out of this, and I'm going to go ahead and open up Esky. There we go. So for this one, you're going to want to go over to, come on, don't be pokey. So for this one, you want to go all the way to independent groups comparisons. So this tab is called independent groups comparisons. And what you can actually see is the data that we had in our table. So this is the data for Bushman 2005. We have the number of people in each group that were shown either neutral content, violent content, or sexual content. It's 84 people in each group. And you can see the mean of brands recalled per each group and the standard deviation for each. What I want you to notice is that the means are different. So our neutral group recalled about an average of 5.76 ads. So they almost recognized half of the brands they saw. The violent group saw or recognized 4.36 ads, and then the sexual content group got 3.54 ads. Now, another thing that I want to show you really quickly, I'm going to zoom in so you can see this a little bit better. The standard deviations for each of these are all really close to each other, meaning that we have homogeneity of variance. We can assume that all 3 part groups are drawn from the same larger population because they have equal sized standard deviations. Now here, you can see our margin of error for each. Our margin of error is calculated as 0.545. so you can see the confidence intervals for each of our three groups. Now, here's where we get to have some fun. So I'm going to zoom out a little bit so that you can see this better. So up here in the green box, we get to compare some means. And we're going to get a confidence interval on the difference. And we're going to get a margin of error, a degrees of freedom, and if we choose to select it, a p-value. So here we have some radio buttons that allow us to compare means. So basically, what we're going to do is we're going to select one of our three means from the top, and then we're going to subtract the mean on the bottom from it. So what is a comparison that y'all are interested in seeing? So we have neutral, violent, or sexual. Which pair should I compare? Somebody give me an example. Which pair should I compare? What? Huh? What? I can't hear. Violent versus what? So we need to compare two groups. So which two groups are we comparing? Okay, so let's go ahead and see if there's a difference between violent and sexual. Violent has a higher mean. So what I'm going to do is I'm going to pick the radio button for M2. And then I'm going to select the one for sexual content. So basically, we're saying this minus this. We're saying this minus this to calculate the confidence interval on the difference. So notice what happens when I do this. Notice that the one for neutral content has been grayed out. We are not focusing on that right now. Here, you can see our confidence interval on the difference here. And here's our difference axis. Here is our point estimate. It's about 0.75. Actually, it's about 0.82. You can see that up in the green box on top. And notice our confidence interval on the difference is very broad. But it doesn't quite touch 0. So our confidence interval ranges from 0.04 to 1.5. So what this basically tells us is that there's either almost no advantage for violent content over sexual content to a 1.6 advantage in recognition. You can see the margin of error and the degrees of freedom. And if you're interested in a p-value, the p-value is 0.03. So while there is a bit of overlap here, this is still a significant difference with an advantage for violent content over sexual content. So basically what this tells us, looking at this comparison, is that sexual content draws more attention away from advertisements than violent contents do. So I guess if you want somebody to buy your product, don't put it on a program with a lot of sexy content. Apparently it doesn't work. Okay, does anybody want me to do a different comparison? Yeah, Sarah, what do you want? Okay, so I'm going to pick neutral as my top one because it's a higher number. So we're going to do neutral minus sexual. Look at that. It goes off of the difference scale. So the effect size, the difference between our two means is 2.2. And then our confidence interval actually ranges from about 1.45 all the way up to 3. This p-value is less than 0.001. So there's definitely a major difference here. And then if you wanted to, you could do neutral versus violent, and you would get a very similar sort of difference. So that's really all you have to do to find these comparisons. But I want to bring up a couple of things that I think are really important to share with you. One of the things that I noted is that there's some homogeneity of variance here. So we need to have some basic assumptions for a one-way independent groups design. First of all, our samples are independent of each other. Additionally, each needs to be a random sample from a normally distributed population. And remember, this is a robust assumption. We can do this with a convenience sample, and technically we can still do the test. We're allowed to violate this and still do the test. However, if you are using a convenience sample, make sure that you are careful about the conclusions that you draw. And then finally, you do need to have homogeneity of variance. The population underlying each sample needs to have the same standard deviation of sigma. And to assume homogeneity of variance, we're going to prefer that the largest standard deviation that we see is not more than twice the smallest one. And we actually found in our example from Bushman that all of our groups had very similar standard deviations, so we can assume homogeneity of variance. So that's when we're looking at a comparison. Now, we're going to look at something that is called a contrast. So a comparison is looking at the difference between two means. A contrast is going to be a bit more complicated, and it can ultimately summarize larger trends. So we can do what is called a subset contrast. So we can look at the mean of one subset of means minus the mean of another. So I'm going to give you an example from Ratton in 2012. So I just gave you a lot of feedback on your writing, and you get feedback from a lot of your different instructors. So here's my question. What kind of feedback do you think really motivates you? How many of you are motivated by tough love, like toughness, like challenging? Okay. How many of you want reassurance? Like it's going to be okay. How many of you want encouragement? Okay. So one of the things that we're going to find is that motivation may change based on the different type of feedback that you get. So in this study, Ratton had students imagine that they got a low grade on a quiz. And I got to tell you, me personally, I don't like how this is set up because imagining is not the same as actually experiencing. But they had to imagine that they got a low grade on a math quiz. And I know that some of you are like, Dr. Gilchrist, I don't like math. This would not bother me. But they were presented with one of 3 different types of feedback, and then they were asked to rate how motivated they are. In a control condition, people got positive encouragement. So basically they got, you know, you can do this, you'll do better on the next one. They got positive encouragement, and then 2 other conditions were added. They either got a comfort condition where they got positive encouragement plus reassurance. It's not so bad. It'll be okay. Please don't feel bad. Those kind of statements. Or they got positive encouragement with a challenge. And so based on this, we can look at different types of contrasts. So for example, let's say that we want to compare reassurance, conditions where people get reassurance compared to when they don't. So we can do what is called a subset contrast. So I'm going to go back into Esky. We're going to go to our next tab, which is called Independent Groups Contrasts. This is not the data that we needed. I needed different data, and it is not here. Let me see if I can paste in some data. Let me take a look. Yeah. I don't think I can here because I can't copy and paste that data. That picture is not very large. I will show you a different contrast in a minute, but let's go ahead and take a look at this example. So this is based on prior data that I guess I don't have access to. So they decided to compare comfort as its own subset and challenge and control as another. So basically, we're looking at the presence of reassurance versus no reassurance. And basically, instead of radio buttons, we now have checkboxes. So for our first subset, we've checked the box for our challenge condition and our control condition. They're going to be it's going to be its own subset. And what's cool is it's basically going to calculate a mean based on the average of these two and its own confidence interval. And then we have our comfort subset, which is right here. And in this particular case, the difference looks similar to different comparisons. So here we have our confidence interval on the difference. Notice that my mean for my challenge and control condition minus my comfort condition, you can see there's no overlap there. There's probably a big difference between these two groups, and it turns out that there is. The confidence interval on the difference shows that not providing reassurance, so either just providing positive encouragement or challenging students, produces around a 1.5 increase in motivation. So the contrast is about 1.5, and it ranges from a low of 0.59 to 2.546. This suggests that feedback that includes comfort actually leads to math motivation that is about 1.5 units lower than the other two conditions. So now we're going to try this with 6 groups because Dr. Gilchrist likes to go big or go home. So this is something that I care a lot about. I care a lot about trying to be healthy so that I don't get Alzheimer's disease. I've had 2 grandparents that have had it. It doesn't seem like it's a lot of fun. There's a significant financial burden. There's a significant caretaker burden. So Halagapa and colleagues back in 2007 were wondering, could diet be a factor? Now let's be very clear. They did this with mice. And you know that mice are very different from people, but they did this with a few different mice. So they had mice that were genetically prone to Alzheimer's. Now, again, let's be very clear about something. There is no Alzheimer's disease in mice. These were mice that were genetically bred to basically look like they had dementia, in as much as a mouse can have dementia. So we have either normal wild type mice, or we have ones that are genetically prone to display Alzheimer's-like behaviors. So we have 6 different groups here. So already one of our major comparisons is normal versus Alzheimer's prone. That's our first major consideration. Then we have different age groups. Some were tested at mouse middle age, which is 10 months. So basically a 10-month-old mouse is equivalent to a 40-year-old person. Interesting. Okay. And then others were tested at elderly mouse age, which was 17 months. And then some were put on a restricted diet, others ate freely. So we've got these 3 different factors that we're varying to create 6 different groups. So mouse cognition was ultimately measured as time spent near a target in the Morris Water Maze. Does anybody remember me talking about the Morris Water Maze in a few classes? Anybody want to share what happens in the water maze? Sarah, what happens in the water maze? Right. And the faster they swim to the platform, the greater evidence that they've formed spatial memory. Good job. So basically, higher values indicate better learning and memory. And because we have a lot of different groups, there are a lot of different comparisons or contrasts that we can make. So I'm going to go into Esky. Here's our data. So you can see we've got 19 mice in each group, and I've made sure to have good labels for everything. Here we have the margin of error for each group, the upper bound and the lower bound for all of our confidence intervals. So we have everything we need here. What do people want to compare here? Do we want to look at Alzheimer's prone versus not our wild type mice? Do we want to look at age? Do we want to look at diet? Do we want to look at specific groups? Does anybody have anything they want to explore here? You know, you want to. Well, I'm always interested in the role of genetics. So here's what I'm going to compare. I'm going to compare all of our normal mice to our Alzheimer's prone mice. So here's I'm going to scroll down so I know which is which. So I'm going to zoom out just a little bit. So I'm going to pick a subset of N-free 10. We're going to pick N-free 17. And then we're going to compare, I'm going to go ahead and compare the free groups because our, none of the normal wild type mice are put on a restricted diet. So I'm going to go ahead and compare the normal versus Alzheimer's groups. And I'm only going to look at the Alzheimer's prone mice that freely fed. Now take a look at that. Now, this is a case where the difference between our wild type mice that ate freely and our Alzheimer's mice that ate freely, there is more of an advantage for our wild type mice, but notice that it crosses 0. So here you can kind of see the difference between our groups. So we have the mean of our different subsets, and then we have the difference between them. Let me see if we can see that difference. So if we look at the difference is only about 4.55 in terms of percentage of time near target. The confidence interval actually ranges between -0.6 all the way to 9.7. So it could be that there's a slight advantage for the Alzheimer's prone mice up to no difference to a large difference. However, if we take a look at the p-value, you can see that this is not a significant difference. The p-value is about 0.08. So that's one comparison we could do. Does anybody want to look at another comparison? Do we want to look at Alzheimer's mice on a restricted diet versus Alzheimer's mice on a free diet? Okay, so I'm going to make my subset again. I'm going to collapse across my age groups. So I'm not going to look at age. So I'm going to do another contrast here. And folks, this is basically, you're going to use the independent groups comparison for your homework assignment. And what you're going to have to do, by the way, this area that says full data, you're going to have to copy and paste in the data here. So what'll happen is that if I pick this, I can enter in the data here. So you're going to have data from 3 groups that you're going to have to enter in here. But going back to our contrasts, so I'm going to go ahead and pick restricted minus free. So we have our diet 10 and our diet 17. And then I'm going to pick free. And I'm going to pick free. And that actually is a pretty large difference, isn't it? So these are our mice that are on a restricted diet. This is our 10-month, this is our 17-month, and we've collapsed across age groups to basically get this mean. Here, we have our free feeding group. And you can see that there's a pretty large difference there. And it turns out this difference is about 8%, almost 9% more time between target, with a confidence interval ranging between 3.6 all the way up to a high of 14% of time spent near target. And this is very highly significant. So looking at this particular subset contrast, we would draw the conclusion that ultimately being on a restricted diet seemed to delay, not necessarily delay symptoms of Alzheimer's, but it didn't hurt learning and memory as much as the group of mice that ate freely, provided that they were prone to Alzheimer's. So there are a lot of different ways that you can look at this. By the way, let's say that you wanted to compare free at 10 versus free at 17. So here's free at 10, here's free at 17. Notice it's not doing any collapsing. If you only look at one group per subset, you're basically doing a standard comparison. So this can do comparisons and contrasts. So there are a lot of different things that you can do here. So what we have done here, so I showed you a few examples. Here, we're looking at middle-aged versus old groups of mice. So here, you can see there's not really a lot of difference between our groups when we compare middle-aged mice versus our older mice. Here, we are looking at the subsets that I showed you before. The group of mice that were Alzheimer's prone on a restricted diet versus those that ate freely. And ultimately, we see that the diet lessens a decline in mice with Alzheimer's. You can look at the data and see that very clearly with the confidence interval on the difference, and additionally, the lack of overlap between our two groups. So, none of what I have done today would be considered a planned contrast. I mostly just wanted to play around with the data. So a planned contrast is going to be a comparison or a subset contrast that we have specified in advance. And ideally, remember our rules of open science, you would want a pre-registered data analysis plan. Now, here are 2 good rules of thumb. First of all, and I'm going to stop with this slide, you need to specify a limited number of contrasts in advance. You can't choose your contrasts after collecting your data because you look like you're cherry picking. Now, here's the other thing. You saw all of the different contrasts that we could do when we had 6 different groups, right? There are a lot of different things you could do, but here's the thing. So let's take a look at this. So if I have 2 groups, there's only 1 comparison that I can make. If I have 3, I have 3 comparisons that I can make. I have 3 subset contrasts that I can make, leading to 6 total. If I have 4, I have 6 comparisons I can make. I have 19 subset contrasts, leading to 25 in total. We had 6 conditions with our mice study. That leads to 15 comparisons, 286 subset contrasts, leading to 301 total contrasts. You cannot do all of that. And one of the other things that I'll mention, the more comparisons or the more contrasts that you do, the greater likelihood there is that you get a false alarm. If a study has K groups, try to aim for K-1 comparisons and no more than that. So if you have 3 groups, only choose 2 comparisons. Don't pick all 3. If you have 6, only do 5 comparisons or contrasts. Examining more than that will lead to contrasts that are not independent from each other. And for more than 2 or 3 contrasts, interpret with caution. As the number of contrasts increase, you have a greater likelihood of falling for a false alarm and inflating your type 1 error rate. So we'll finish this up on Thursday. If we have leftover time on Thursday, you can start doing some work on your paper or the homework assignment. And I will upload this to YouTube tomorrow. And I will see you all then. Hey.